Alright, so today we'll be talking about overscan. So basically having overscan in your renders allows you to do post camera shake, or you want to compensate for pixels that got cropped into, or when you apply lens distortion or anything to your renders. So basically allows you to have more uh, pixels around your usual render resolution. Okay, so there's two methods to do it from Maya. Okay, so the first method is by going into, okay, so let me just do a test render. Okay, so this is a test render in your regular 2K resolution 1080. Okay, and then if I go into system, okay, under render settings, you'll see that there's this option called overscan. Okay, so this is where you can input the amount of overscan that you need for your renders. Okay, so there's a catch to this. If you are using this method by changing render settings and using the overscan here, it only works if you batch render your renders. Okay, you can't render sequence. You'd have to use the batch render. Okay, I'll show you guys. Okay, so how what's the information that you need to feed in here is the amount of pixels that you need for the overscan. So there's multiple ways that you can do it. You can do by percentage, for example, 5%. Okay, if you input one value, it will means that it applies 5% top, right, bottom, left, all around with a 5% extra. Okay, let's say I know exactly how many pixels I want. I want 50 pixels at a all around. So I'll just put in 50. Okay, but if I were to input two values, so 50 space 100, that will means that the first value is top and bottom, and the second value is left and right. Okay, so it means that 50 pixels more on the top and 50 pixels more at the bottom, 100 pixels more left and right. Okay, so if I were to put in four numbers, for example, 50, 200, 200, and 300, this will means that the top will get 50 pixels more, the right side will get 100 pixels more, the bottom will get 200 pixels more, and the left side will get 300 pixels more. Just think of it in the clockwise rotation, and the values will is relative to the positions of your renders. Okay, so if I were to do 50, 100, 200, 300 like that, so it means that my left side will have 300 pixels more. Okay, so maybe let me just do a normal render without the overscan first, so that we have something to compare. So let me just do a quick render. Okay, let me open up the folder, overscan folder. Okay, render. Okay, I want to render to there, so I will go into okay, let me double check all the settings. So 2K main cameras, that's good. Okay, render. Okay, so since I know for sure that that it doesn't have any overscan or anything, I can just use the render sequence. Okay, they change this to main camera, and then it'll be rendering into the render folder. Okay, that's good. Okay, render. Okay, so now inside the render folder, I will have my master layer, which will eventually have my overscan render. So just let it render. There's a documentation, by the way, in the Autodesk website. So it also has explains, like you see, if you input in one value, it means that the value is applied all around. Two values, the first value is top and bottom, second value is left and right. Okay, three values, you get your um, I mean three sides, and then one of it is second value is bottom, and then third value is the margin. Okay, top, right, left, and the bottom. Yeah. So if you guys don't understand what I've talked, you guys can go and read the um documentation for better understanding. But yeah, I think it's very straightforward lah. So just listen to me talk. It's fine. Okay, so the render is done. Okay, so let's just quickly take a look at the renders. Yeah, it looks good. Okay, let's double check the resolution. Okay, so it's 1920 1080. Okay, so this is expected because it's the default render, right? So let's just name the file properly. So this is my let's say this is my environment, and then this is the normal EXR. Okay, which doesn't have overscan. Okay, so now we want to try to apply the overscan to it. So what we'll do is we'll go into the system render settings under overscan. So like what we tried just now, we want to increase the more pixels all around it. Okay, so what we'll do is we'll increase maybe 50, 100, 200, 300. Okay, so that will increase more pixels around it. So this will actually means that I will have a longer render time because now I need more pixels. And like I mentioned previously, it only works via batch render itself. Okay, so if I were to use batch render, it will be rendering into my, because I didn't set project, it goes into my default images. Okay, so let me just do that, batch render. Okay, and then I will go into the folder itself. Okay, so under Maya, okay, if I bring over, you can see that inside my default um, directory, it will be rendering the renders with the overscan. Okay, so let's just see. Yep, it's still rendering. So same thing, let's give it a while and wait for the renders. Okay, so the render is done. I'll just copy it into the the folder where I stored my previous render. Okay, and this will be my environment with overscan. Okay, so now I have two renders, and let's just double check this render. As you can see, the file size is already bigger. And if I were to look at the information, it should have, it's not showing me the full resolution, but never mind. Let me bring it into, wait, I think it's there. Let me just double check the information. Okay. I think the information is there. You see, like the min Y has 50 pixels, min X has 300 pixels. Okay, but anyway, let's just take a look in Nuke itself. Okay, so now if I were to go into Nuke with my new renders, so if I go to Nuke, okay, bring in the renders. Okay, for some reason, I think because it's still rendering, so my computer is eating up all the memories trying to do the renders. Okay, I need to stop my batch render. Give me a moment. Cancel batch render. Yes. Okay, so it's done. Go back to Nuke, and then we import in the renders. Not this folder. Here. Okay. Okay, so this is our regular render. Yep. 1920 1080. Okay, looks fine. Okay, so how we can check whether it has overscans or not? Very simple. You add a transform, and if you were to shift it, you'll see that the edge turns black and there's no alpha. So basically, it means that you don't have pixels outside the renders, right? So if you were to do your camera shake, eventually in post, you will not be able to have those information there. Okay, so if I were to look at the renders that was rendered with overscan, you can clearly, from the first look, you already know you have extra pixels on the outside. You can see the bounding box has is bigger than your canvas, right? So you have 50 pixels here, 100, 200, 300. Okay, so now if I were to add a transform, you'll see that I can actually reframe my scene. I can change the overall look already. So that this is how we get the overscan, and then of course when you're doing a proper comp, you want to reformat it eventually back into your regular 2K. So you output in your 2K, which is your HD 1080, and yeah, that's it. And then I mean, if you were to do your camera shake, and then after that you just need to reformat it back, and then you can see that it looks exactly the same. And then I think the transform, why is it not moving? Oh, it's moving. It's just that. Yep. And then you see you can do your the repo like that. Of course, you can do your shake if you need to, and then yeah. Okay, so this is the first method to get your overscan. So first method, and the second method will be, so if I were to go back, okay, let me just delete all this thing. Okay, if I were to go back to Maya under system, let's remove the overscan. Okay, so the second method is very simple. You input the values directly into the image size itself. Okay, so for example, 1920 by 1080. Okay, so the limitation in this second method is you cannot apply custom values to each side of your frame. You need to put in, like for example, 10%, 5%, a generic amount that will be applied throughout the whole, all around your renders. Okay, so for example, I want to do 10% more. So we'll just use 1920 times 10%. So let me just use my calculator a second. 1920 times 10%. That will be 2112. Okay. Then we use our 1080 times 10%. That will give us 1188. Okay. So if you change it this way, of course, you will get a bigger render. And you also need to remember to go into your camera and change the camera scale to 1.1 as well. So it has the increase of the 10% in the camera scale itself. Okay, so I repeat myself. So you need to change your image size with the extra pixels, and you need to go into your camera itself under camera scale. You need to input in the amount of um, basically how much more that you have added to your renders. Okay, so 10% 1.1, 20% 1.2, etc. Okay, so once we are happy, same thing, we can just use our this one render sequence should work. So let's just try render sequence, render into our render folder. Okay, now if I were to view my renders, not this. Okay, here. Okay, if I were to view my renders, it should be here. And let's just wait for a while for it to be done. Okay, so we have the render. I think it's still rendering. You can see the file size. Yeah, it's still rendering. But if we look into the information, you can see that it has the bigger numbers now, right? It has the 10% that was added on top of your 2K render. Okay, so let's just continue waiting. Okay, let's just import in. I think it's still rendering, but let's just try importing into Nuke and see what it gives us now. Okay, let's just import in this. Okay, so our regular renders, and then the one that we did with the overscan, and this one is manually inputting additional 10% all around. Okay, I think it's still rendering. It refused to let me load. Maybe I should just cancel the render so that it doesn't take too much time. Yeah, I think I can. Let me just double check. Images. Not this one. I think I can close this. This one close. Okay. I think I probably can stop the renders. Let me just press escape. Okay, stop the renders. Okay, so the render is done. Let's just check it in Nuke. Okay, so if I view from here, so if I view the original renders, the overscan, which looks exactly the same, and then if I view the normal and the one with the extra pixels that was added, you can see that it got pushed back, right? Because it has more pixels and it tries to fit everything in within the canvas, so technically your image got scaled down, right? So this is representation, but this is not what we wanted, right? Because we want it to look like how it was, just that with the extra pixels. So what we'll do is we'll add a reformat. Okay, and this is where, okay, so you see now reformat with the resize type set to width, it gives us this weird thing. Okay, so what we want is change it to none. Okay, and change the output format to our just our 2K. There you go. So if we compare this to this, now it's the same. This to this, you see the zoom out, and then after the reformat it looks exactly the same, but same thing, if I were to add a transform, you'll see that I have extra pixels all around that I can play with. So I can, let's say I reposition it, so it still will work. Okay, so yep, so this is how you can do overscan renders in Maya Arnold. Two methods. Personally, I recommend the one that is setting the overscan correctly, so that you can specifically assign the values to the each side of the render. So in a way that you are optimizing a render, because if say I don't even need the bottom, my camera shake is just the top part of my scene, I can just do an overscan for the top section of the renders instead of having it all around, basically wasting render time that is not needed. Yeah, so that's overscan. Alright, so thank you guys for watching. If you got any question, feel free to leave in the comment section. And if you are still not a subscriber to the channel, don't forget to click the like and subscribe button. And I'll see you guys next video. Thank you. Bye.